once all of these things are done, like, I will say this. If this is all done and then nothing else ever changes after that, then I'll be extremely happy.
Welcome to Bankless, where we explore the frontier of internet money and internet finance. This is how to get started, how to get better, how to front run the opportunity. This is Ryan Sean Adams. I'm here with David Hoffman, and we're here to help you become more bankless. Guys, we have a fantastic episode today with Vitalik Buterin. We talk about the future of Ethereum, the rise of alternative layer ones as well. A few things to watch out for as you listen to this episode. The first is we talk about the Ethereum roadmap from the guy who actually helped create Ethereum, how far we are in the Ethereum roadmap as well. That's number two. Number three, what will Ethereum look like when it's all said and done? How long will that take? Number four, can centralized alternative layer ones become decentralized in the long term, or will they remain centralized? Number five, what does Vitalik make of the term Ethereum Maximalists? Number six, will crypto actually be able to solve the big scale global problems in the 2020s in this decade that we're in? David, this was a fantastic episode. They're all fantastic with Vitalik. I hope folks listen to each and every single episode with him. What did you think about this episode?
I think this is the perfect episode to kick off 2022. This is a hybrid podcast. One side of it is very granular and detailed. That's the first half where we talk about the Ethereum roadmap, just contextualizing and grounding people in what's left with Ethereum. Some of the obvious stuff comes up first, like the merge and sharding, but then there's a bunch of other things as well. And we talk about those things and why we need them and what they do for Ethereum, both now and into the long term. And then we actually fold that conversation into the conversation of the growth of the alternative layer ones. And we talk about how the first half of 2021 was more or less Ethereum's show. Ethereum, just massive success in the first half of 2021. And then the alternative layer ones came on the scene. And now there's this growing ecosystem of many different chains, all doing more or less similar things with different design structures. And a lot of them have chosen centralization as their competitive advantage, if you will. And so getting Vitalik's take on that in relation to the Ethereum roadmap, because some of the things we talk about in the roadmap actually lends itself directly towards how some of these centralized layer ones can actually migrate into a long-term sustainable, robust ecosystem. So Vitalik not only is unpacking the Ethereum roadmap, but also proposing a roadmap for alternative layer ones to actually be successful into the long term. And so I really enjoyed that conversation. And then, of course, just zooming out and grounding ourselves, not just inside of the crypto industry, but inside of the world at large. Where are we in the 2020s as humans, as crypto people? What's up with the 2020s and what can we do about it?
Yeah, I think that's been top of mind for me, David, because like going to this decade, we're just 1 year into this decade, but we have 9 more to go. And I'm a little worried, I'm a little concerned about where this decade might leave us, but crypto is the thing that keeps me hopeful. And seeing Ethereum's roadmap laid out like this also makes me hopeful and bullish on Ethereum. I've never seen Ethereum's roadmap as clearly articulated and stated.
Having a precise and concrete roadmap is actually a luxury in the Ethereum world. And this is not something that we could have talked about in this depth and with this much future in mind up until now. So I'm really excited to just unpack all of the Ethereum roadmap with you, the listener. And also, what I'm also excited for you, the listener, is to like the video, rate and review us on iTunes or wherever you get your podcasts. And if you're watching on YouTube, make sure to subscribe. So let's go ahead and get right into the future of the Ethereum roadmap and the rise of the alternative layer ones right after we get to some of these fantastic sponsors that make the show possible. Hey, Bankless listeners, at the end of this podcast, Ryan and I unpack this whole entire episode in our debrief. This is something that we only give towards our premium subscribers, but since it's such a good podcast and it's also the first episode of 2022, we've decided to release this one for everyone. So at the end of the podcast, or if you're watching on YouTube in a separate YouTube video, there is a 30-minute debrief where Ryan and I unpack the episode, talk about the strategies for alternative layer ones, talk about how we're all getting to this end game state that we are apparently all converging on, and unpack the other, crypto topics that we have seen in the latter half of 2021. So stay tuned for that. And if you want more of these debriefs, subscribe to Bankless, because we do one for every single podcast that comes out. Bankless premium subscribers have a private RSS feed that they get these every single week. And so if you like what you hear, go ahead and subscribe to Bankless and you will get that every single week automatically downloaded to wherever you get your podcasts. Cheers, and I hope you enjoyed the debrief. Arbitrum is an Ethereum scaling solution that's going to completely change how we use DeFi and NFTs. Over 250 projects have already deployed on Arbitrum, and Arbitrum's DeFi and NFT ecosystems are growing rapidly. Arbitrum increases Ethereum speed by orders of magnitude for a fraction of the cost of the average gas fee. When interacting with Arbitrum, you can get the performance of a centralized exchange while tapping into Ethereum's level of decentralization and security. If you're a developer who wants low gas fees and instant transactions for your users, visit developer.offchainlabs.com to get started building your application on Arbitrum. If you're a user, keep an eye out for your favorite DeFi apps or NFT projects building on Arbitrum. Many of your favorite apps are already live, with many more coming over soon. You can find these apps at portal.arbitrum.one, and you can bridge your assets over to Arbitrum using bridge.arbitrum.io in order to experience DeFi and NFTs the way it was always meant to be: fast, cheap, and friction-free. When you shop for plane tickets, you probably use Kayak, Expedia, or Google to compare ticket prices. So why would you limit yourself to just one exchange when you trade crypto? When you make your trades, you want to make sure you're getting the best possible price on your trade, and that's why you should be using Matcha. Matcha has smart order routing that splits your trade across all the various liquidity sources in Ethereum, and is also operational on Polygon, Avalanche, Binance Smart Chain, and other chains. Trading on Matcha is super easy because it pools the liquidity for me in a single, easy-to-use platform and allows me to make limit on-chain orders, so you can set and forget your DeFi trades and they will go through automatically while you're away. So when you're making a trade, head over to matcha.xyz/bankless and connect your wallet to start getting the best prices and most liquidity when you trade your crypto assets. Bankless is proud to be sponsored by Uniswap. Uniswap is a new paradigm in asset exchange infrastructure. Instead of a cumbersome order book system where trades are matched with other humans, Uniswap is an autonomous piece of software on Ethereum that lets you trade any token at the current market price. No human counterparties or centralized intermediaries, just autonomous code on Ethereum. Input the token you want to sell and receive the token you want to buy. The Uniswap Grants program is accepting applications for grants. Do you have something of value that you think you want to contribute to the Uniswap ecosystem? No matter how big or small your idea is, you can apply for a unique grant at uniswapgrants.org and help steer Uniswap in the direction that you think it should go. Thank you, Uniswap, for sponsoring Bankless.
Bankless Nation, we are super excited to introduce our next guest, who requires no introduction, really. Been on the podcast multiple times. Vitalik Buterin is on Bankless today. He's the creator of Ethereum, writer at vitalik.ca, a popular Bankless guest. We have a number of episodes with Vitalik. Welcome back, Vitalik. How are you doing?
Thank you. It's good to be here.
Well, we want to talk about a few things today with you. The Ethereum roadmap, of course, the rise of L1s. That was something that happened last year. The Endgame. This is an article you wrote called The Endgame, which chronicles, I think, or describes maybe an endgame situation for all blockchains, all layer ones. But we also have the privilege of recording this toward the end of the year. So we can't pass up an opportunity to talk about some reflections for 2021, just to get us kickstarted. So what did you think of 2021 for crypto? Like high level, okay? A lot of people say it was a very good year for crypto. I think they're mainly talking about prices. Maybe they're also talking about adoption and mainstream attention. What are your thoughts on 2021? Was it a good year for crypto? What did you think about it?
I definitely think it was a great year for adoption and for mainstream attention. The rise of NFTs was definitely something really fascinating to see, and I think it's brought a lot of people into the crypto space that would not have gone into it before. I think things like well, at least to me, like blockchains are about creating these innovative new ways to organize society, and in some ways, to me, like what's happening with artists being able to sell NFTs really is a realization of that spirit, because like we actually are giving people who are creating art new business models. We're giving the creators of this thing that's very valuable, but that often has a hard time getting business models, a new way to actually get funding. So that's something that's been very interesting to and exciting for me. The rise of DAOs is definitely also interesting and exciting. We've been seeing more and more DAOs that are actually doing lots of interesting things, experimenting with different governance algorithms, projects like CityDAO that are actually trying to do things in the physical world. So that has all been fun. Um, the progress that we have seen in layer 2 scaling, I think, has been really amazing. Like, we've actually, I think, over the course of this year, really seen layer 2s go from theory to practice. At the beginning of this year, there were only like one or two layer 2s on mainnet, and they either pretty much all only supported a couple of applications. And now we have this thriving ecosystem, and people are really experiencing what a layer 2 Ethereum looks like firsthand. So lots of progress on adoption, lots of progress on tech, definitely lots of happy things to report this year.
Vitalik, one thing I've gathered while being in this space for a number of years, I got in 2017. Ryan got in a little bit before me, but I hear all these crazy cerebral conversations that happened in the Bitcoin space, in the very early Ethereum space from 2011 to 2015. And just like about what the possibilities of crypto could be. And I'm, from my perspective, my limited perspective, because I've only been here for so long, is that 2021 was a year where so many of these high in the sky, like, very, very cerebral possibilities of crypto actually started to happen. Like NFTs and unique tokens were a conversation very, very early, as well as DAOs, even though we didn't call them DAOs way back when. Would you say that 2021 was the year that crypto actually started to unlock some of these early theorized use cases that were, only conversations back 5 years ago?
I would definitely say so.
Fantastic.
So Vitalik, let's talk about Ethereum for a minute. And one of these days we're gonna have you on Bankless and actually not talk about Ethereum, maybe not talk about crypto, because I know you have tons of varied interests and a lot of insights on many topics. But today is not that podcast, okay? We want to talk about Ethereum. Going into 2022 in particular. So when listeners hear this, it'll be the first week of January 2022. We want to talk a little bit about the roadmap for Ethereum moving forward. But before we do, let's talk about the progress Ethereum made last year in 2021. So what were some of the main accomplishments, milestones? I know you mentioned layer 2. That's probably chief among them. Are there any others at the protocol level?
Yeah, so I think if we focus on layer 1, some of the big things are, one is that the beacon chain just proved itself. It's turned from being this very early thing into an increasingly mature ecosystem. It also had its first hard fork, the Altair hard fork, which of course added the kind of basic scaffolding that we need to have Litecoin support, and it was also just the first ever beacon chain hard fork, which is an important trial run for the merge. So the next beacon chain hard fork, and most likely the next execution chain hard fork, will actually be the merge. So that's exciting. Speaking of the merge, we also have testnets for the merge now. The Kintsugi testnet launched a couple of weeks ago. And of course, the Kintsugi testnet was not even the first testnet of the merge. There were a couple of other smaller ones that have been running for a couple of months, but Kintsugi is one that is much bigger than before, many more participants than before, more extensive than before. Anyone could go and participate, and I even got some Kintsugi ETH from the Kintsugi faucet a couple of weeks ago. So that has also been, I think, a lot of great progress. A lot of just interesting infrastructure projects that have been coming of age. So Proof of Humanity has matured a lot, and it's been seeing a lot of usage. Sign in with Ethereum has been seeing a lot of adoption, and that just went from, I think, an idea that a few people were thinking about to something that lots of people are excited about starting to adopt and use over the last few months. Cross layer 2 bridging, still in its infancy, but much better than what it was a year ago, which is basically not existing at all. But account abstraction, there are testnet versions of ERC 4337. This is something that hasn't really gotten into the public discourse yet, but it's moving forward quietly. A lot of progress there. So, lots of small things, lots of progress on the various spec items that haven't been released yet, but that we're going to talk about through the rest of this episode probably. Just like a whole bunch of like really meaningful progress on I think pretty much all of the big things that we care about.
And by the way, for people listening on YouTube, this is the testnet you were referring to, Vitalik, I believe. So, what are we looking at? So, this is Kintsugi, which is the newest. Is this the Beacon Chain Plus, like Ethereum 1 sort of testnet? This is
Yes,
basically the
this is
merge.
a test net of the merge.
Okay, testnet
So
of the merge. So, like, what can people do here? Is this mainly for developers, or is there anything? Is there?
they can connect nodes. They can become stakers. They can launch contracts and trade coins around.
This is
So
it
yeah,
though.
I
This
mean,
is
yeah,
this is the
that's
merge, right? This is the thing
right.
that is going to be put in production. So what has to happen between now and like the time the merge goes through? Is it just a lot of testing, a lot of, validation?
Yeah, definitely a lot of testing and auditing and all of that. The one piece that I'm aware of that's like still the furthest from being certain is how clients would sync after the merge. Basically the the problem is that the way that proof of work syncs and the way that proof of stake syncs are a bit different from each other, and so there's a bit of engineering that needs to be done to put the two together. But this is something that people have already been aware of for a while, and so there's a lot of things in progress and being implemented. So I think so far things are mostly going smoothly.
Taking another opportunity to zoom out, the Ethereum protocol has developed throughout 2021, but there's also what I like to call meta development, which is just defining and understanding the long-term roadmap of Ethereum to an actual concrete specific detail. And sometimes in Ethereum's history, there wasn't all that much that with regards to details in the future. I remember in 2017, I didn't really know what was going to be happening next in Ethereum 6 months out, but it seems to be that the meta development of Ethereum has gotten a lot more robust, and partly that's illustrated by that infographic that we're going to pull up here in a second. But Vitalik, Ethereum changes every single year. 2015 Ethereum is different than 2016 Ethereum, and so on and so forth. How would you contextualize overall with the grand Ethereum vision for what it wants to be, and then also where it is in 2021? How far along are we? Are we like 60% of the way there? Are we 40% of the way there? And then if we could just like give a grade towards just the progress made so far, how would you evaluate it?
I would say around 50. I'd be willing to go past 60 once the merge is fully complete, and I'd be willing to go past 80 once we have a full sharding implementation. But I think those two biggest items are definitely getting closer and closer, but they're not yet in the rear view mirror.
That's really cool. Over 50%. We're getting close then. Very neat. So let's talk about what's coming. So David used this term, I guess meta development, the roadmap. Roadmap to me, at least this year, for Ethereum has never been clear, which is super cool. And you put out this infographic on Ethereum's birthday. Sorry, not its birthday, the Beacon Chain launch birthday, December 1st, that kind of highlighted progress across a number of different work streams. So I'm going to go through those really quick at the high level, and then let's take some time to talk about each of them. So, and by the way, I love these nicknames that you used, you christened. They have a nice flow to them. The first is the merge. The second is the purge. Then we get the Verge. Sorry, I messed this up. The first is the merge. The second is the surge. The third is the Verge, the purge, then the splurge. So these are 5 different work streams. The merge is really when proof of stake comes about and proof of work finally dies. The surge is about scalability, particularly for rollups. We'll talk about that. The Verge is all around stateless clients, making Ethereum nodes easier to run. The Purge has a bit of technical debt elimination, but also eliminating historical data if you want to find out more. And the Splurge, of course, any good splurge is, all about the extras, all about the goodies. And so we got some goodies on the roadmap as well. I'm going to show that infographic as we talk about each of these areas. But like to me, the Ethereum roadmap has really never been clear, and maybe we could address these things one by one, Vitalik. So let's talk about, and I think they're kind of in order maybe of how soon they're going to happen. Is that the case? So the merge is going to happen
No,
first.
so time is left to right.
Okay, time is left to right.
There's no top up to down time dimension.
Okay.
Hence why the time arrow at the top goes left to right. So
Okay, very
everything is
good.
parallel.
But we should say the merge is probably going to be the thing that's happening first. And maybe we should start with that. So tell us about the merge.
Sure. So the merge is the same thing that the merge has always been. It's the full transition away from proof of work to proof of stake. So there has actually been there's a lot of stuff that has already been done for proof of stake that's in the kind of what's already behind us column to the left. So the beacon chain already exists. There's already been a warm-up fork. Proof of stake already has light client friendliness. But what's left to actually get to the merge, right? So the most recent thing that was finished is the full specification of the merge process. So the specification, not just of what post-merge Ethereum looks like, but even of how the transition process works. So how the process works of like actually changing from one to the other, what is the final proof of work block going to be, how is the first proof of stake execution block going to point to that proof of work block, what happens during edge cases, like what if the chain reorgs right in the middle of that. So all of that's the spec. So this exists. So that's what these testnets have been running. That's what Kinsuki has been running. So full merge specification, test networks in progress, fork choice improvements. So basically there just have been a few bugs that have been discovered in the fork choice rule. This is the function that nodes use to determine like which block is the head block if there are multiple competing blocks based on all of the votes that all the different validators have made. And this is just like adding some armor to make it more robust against certain kinds of attacks. So once that's done, then the merge can happen, right? And once the merge happens, then no more proof of work, right? And so then that's the merge. After the merge, we have the post-merge hard fork. The most important feature of the post-merge hard fork is just enabling withdrawals, right? So the merge itself, just to keep it simple, does not enable withdrawals. But the post-merge hard fork, which there is a spec for enabling withdrawals, but this is something that will actually needs to be done a little bit later.
Just to be clear, Vitalik, this is about withdrawals for beacon chain ether depositors and validators. So
Correct.
This isn't about tokens or anything else, right?
Exactly. So if you threw your 32 ETH in and you're a validator, then once the post-merge hard fork happens, you will be able to withdraw the ETH and the rewards and bring it back into the execution layer.
And
will everyone be able to withdraw all at once, or how is that?
There's a queue. So if lots of people start withdrawing, then lots of withdrawals will have to wait.
And so to be clear, Vitalik, those are happening in two different hard forks, right? Two different stages here.
Mm-hmm.
And any idea on how far they will be apart? Will these be like months apart, weeks apart?
Realistically, like maybe 6 months.
Okay, 6 months apart. Okay, so that's the merge, and that means proof of work is gone effectively. We just have proof of stake. What does this mean for the typical user or the typical DeFi application? Will they have to do anything? Do they have to click a button in MetaMask that says like upgrade to merged ETH?
I mean, they'll have to upgrade to merged MetaMask, but they will not have to upgrade their ETH or their applications. So from the point of view of applications, like it's just like any of the hard forks that we've already been through.
So effectively nothing. Effectively, users don't have to do anything at all. Okay, so that's the merge. Let's talk about next. And by the way, with the merge, we haven't mentioned, of course, all the proof of work issuance goes away as well, right? So that's something over 4% or so, and that is now gone. No more proof of work issuance. No more miners on Ethereum for the first time. That's going to be an interesting state to be in. That all happens at the time of the first merge. Is that correct?
Yes.
Okay, interesting. Let's talk about the second, which is the Surge. What's the Surge all about?
The Surge is scalability increases for rollups through sharding. So basically, rollups by themselves are a layer 2 scaling solution, and the way rollups work is that computation and storage go off-chain, but data stays on-chain, right? And this allows transactions to happen much more cheaply than they would if everything is done on layer 1. But they still inherit the security of layer 1, right? So rollups are this compromise that basically gives us a lot more efficiency than layer 1 with all of the security that users are used to. And it's kind of the best combination of properties among all of the different layer 2 solutions that have been explored. And it's also, I think, the only one that really properly supports full EVM scripting, right? Like state channels, for example, they support payments. They can support a few applications, but you can't easily stick Uniswap in a channel, for example. But you can stick Uniswap in a rollup. So about a year and a half ago, I think, there was this document that I published called the Rollup-Centric Roadmap, where basically say, look, rollups are realistically the scaling that's going to come the fastest. And so, and we know that rollups work. The theory behind them is extremely well established. So let's simplify the scaling roadmap by kind of re-architecting the scaling roadmap around being based around rollups as much as possible, right? So the main thing that we get out of that is that instead of the sharding that Ethereum has been planning on having all along, being sharding of everything, so sharding of execution, sharding of accounts, sharding of smart contracts, sharding is just sharding of data, right? So it's this very limited form of sharding that basically says, all we're going to do is we're going to have this kind of data layer, this sort of public billboard that people can stick up to around 2 megabytes a second worth of data on. And when they do this, then the blockchain guarantees that data is publicly available. It guarantees that the data actually was published and that nobody is withholding it, but it does not try to interpret the data, right? Now, who tries to interpret the data, that's the job of the rollups, right? So the layer 1 just handles data, and it's the rollups' job to kind of convert this highly scalable data plus the little bit of computation that the Ethereum blockchain gives you into a lot of computation. And we've talked about optimistic rollups and we've talked about ZK rollups before, right? So I think people are going to know roughly how this happens. But the core insight here, right, is basically is that if you sort of lean on rollups as this machine for converting data into execution, then sharding just needs to support data, and sharding can become much simpler. One example way in which sharding becomes simpler is that the sharding design does not need to have any fraud proofs, right? So the sharding designs that we were thinking about earlier, where we actually have execution inside of the shards, we had to deal with this question of well, what happens if one of the shard blocks is invalid, right? Does someone have to submit a fraud proof to show that it's invalid? And what if there is one of these fraud proofs, then does that mean that the entire chain has to get reverted? And there's all of this complexity that we have to deal with, right? But with data sharding, there's no such thing as an invalid block. All there is an unavailable block. And so we don't need fraud proofs. There's just a lot of machinery in terms of managing state, doing cross-shard transactions, just all of this complexity that can just completely go away. And so the protocol can be really elegant and simple, and it's Rollup's job to actually convert this into this kind of high performance, very parallelized but very secure EVM ecosystem. So what this actual roadmap is, right? So we have basically 4 stages here, is basically just adding more and more of this data. Right? So step 1, short-term call data expansion. This is if something like EIP 44, could be something like EIP 4488, could be something like EIP 4490, just adding more data space in the short term to make rollups cheaper. Then we have basic sharding, and steps 2 and 3, actually you add on kind of full on the full on sharding specification, right? So they add on this idea that you have these transactions, and these that can contain a huge amount of data, Except at the beginning, like we might compromise a bit, and we might say, well, everyone still has to download all of this data, but it's just some dedicated space to store the data. And so we're kind of easing into the sharding model, and rollups can kind of re-architect themselves to actually take advantage of this data. And then when we go from a few shards to many shards, like that's when we actually kind of take off the training wheels and we say, like now, finally, we don't need to have any node downloading everything, right? Like we just rely on committees, we rely on data availability sampling, we rely on all of these other technologies to verify that the data exists without requiring any single node to download everything individually. And then the fourth one, data availability sampling. This is this really sophisticated technology that clients can use to basically check that all of the data has been published by randomly checking like just random pieces without having to download all of it. Right? So it's like first add data, then add more data, then add even more data, and then near the end we start adding more and more armor to make sure that we have like both the scalability and the security. So more and more data, and rollups get cheaper and cheaper. And from a user's point of view, like users, once again, they don't really have to notice anything. The only thing users have to do is they just have to move their activity from layer 1 to layer 2 at the point when they're comfortable with it, right? And then once they've moved everything to layer 2, then all that they see is that layer 2 just keeps on getting cheaper, and then it gets cheaper again, and then it gets cheaper again. So that's the surge.
And so when you say the layer 2s just get cheaper and cheaper, are they also getting faster at the same time? Are those hand in hand?
Define faster.
Faster execution times.
Well, no, so the word faster, like I think there's two kinds of fast, right? There's like latency and there's bandwidth. So latency is like how many seconds do you have to wait for even one transaction to confirm, and then bandwidth is like how many transactions per second. So none of what's happening in the surge improves latency. So far, all of this, like, you still have your 12-second slot times. The slot times might even have to increase a bit, to handle sharding. So it might have to go up from like 12 to 16. But what's going to go up a lot is bandwidth, right? So like the Ethereum blockchain today can handle 15 to 40 transactions a second. Rollups today, if they add proper compression, can go up to 1,500 to 4,000 transactions a second, and then rollups with sharding can go up to 100,000 transactions a second. The reason why they get cheaper is basically supply and demand, right? If the chain can handle more transactions, then that means that there's more space and you don't have like all of these users that competing for the same very small number of slots. And so the transaction fees that every single user has to pay just go down by a huge amount. Like that's basically where the cheaper comes from. So it's cheaper because it's a higher bandwidth.
By the way, this bandwidth thing, I think a brilliant site to see this is ETH TPS. I don't know if you've seen this before, Vitalik, but
I have, yeah.
It kind of showcases the bandwidth of Ethereum when you take into account this is Polygon, but also all of the other optimistic rollups and in rollup chains as well. And so Ethereum currently does 65 transactions per second if you add all of that together. And in this block, it's 87 transactions per second. And what you're saying is basically that number will go up and up and up and up for higher and higher and higher with the surge.
Exactly.
And what would this mean for anyone who is still living a life on the layer 1 with the expansion of the number of shards and also the size of shards? Does that mean L1 gas fees are going to come down, or what's the deal with that?
I mean, in the short term, maybe, but I think realistically in the long term, using L1 is just going to keep getting more and more expensive. So you as a user, I think you do need to be prepared for the fact that Ethereum already is transitioning away from being a layer 1 centric ecosystem toward being a layer 2 centric ecosystem. Today, the gains that you can make from switching to layer 2 are maybe only 5x, but in the future there'll be 10x, and then there'll be 50x, and then there'll be 1000x. So eventually all activity is going to have to transition to being layer 2. Eventually, even bridging from one layer 2 to another layer 2 is something that will mostly have to happen without layer 1s. And this is a change that users will have to get used to. I think it's a change that some users are starting to get used to already. But if they can do it, then everything other than that is going to be fairly under the hood for them.
With regards to the shard size and shard count, I want to unpack this one a little bit because we have a couple phases inside of the Surge where first we add in sharding in the first place and just a few shards, and then we add more shards. But from what I've gathered from other people's writings, Polynia's and some other ETH client devs, is that long term, there actually could be no cap on both the size and the number of shards, so long as the resources that Ethereum has to its availability is sufficient. Is that true? And so then a couple of questions to follow up on that. How will we know when we're ready to add more shards? And is there an ultimate final number of like, we are going for this many shards with this size? Or is this a number that's always going to be dynamic in Ethereum's future?
So I actually wrote an article about this like 6 months ago. And if you go to the post called The Limits to Blockchain Scalability, I think. So sharding gets around a lot of the limits to scalability of non-sharded blockchains that I talk about above. So the first limit I mentioned is quadratic sharding, right? Which basically is this idea that like it's the beacon chain is going to contain headers of shard blocks, and then so you have the beacon chain block, and then you have shard blocks. You only have 2 levels. It's theoretically possible to make blockchain designs that have 3 levels or 5 block levels or a dynamic number of levels. And like I remember the Ton network, for example, like they were trying to do exponential sharding, and like they had this dream of going up to 2 to the power of 92 shards eventually. And my opinion is that stuff is possible in theory, but in practice, going beyond 2 levels is just like too hard and it adds too much complexity, and so it's not worth it. So Ethereum is staying with quadratic. But there's other reasons why scalability going too high becomes too risky. And like, there we go. So what are these risks? Excellent. So keep going down. So basically what I talk about here is that as the data capacity of the chain increases, you get this property that because no single user is going to be downloading or processing the entire chain, you get a minimum number of users that you're counting on to ensure that the chain continues to be secure, right? So like, I guess one analogy of this is that if you imagine like a blockchain as one city, and you imagine you start off with a blockchain that's just a small town. How small is the town? The town is so small that if you make one guard tower and you make the guard tower tall enough, then you can have one security guard, and the one security guard can watch the entire border of the town and make sure that no attackers get in, right? So that's like an unscalable blockchain. Now imagine you start scaling the town up more and more. Eventually you get to the point where like you can't have one guard tower in the center, you have to switch to having guards on the walls, and you need multiple guards on the walls. Well, once you get to a town that's like, let's say, I don't know, like has 100,000 people, then, you know, you might have a wall, your wall might be 10 kilometers long, and like you might need, let's say, 50 guards, right? If you have less than 50 guards, then the guards can't see far enough, and so an attacker might slip through in between 2 of the guards. If the city expands further, and then the city is, like, say, as big as Manhattan, then you're gonna need like 1,000 guards, right? And, you know, if you don't have your 1,000 guards, then, you know, like an attacker might slip through in between 2 of the guards, and like the security of the town might break. So the bigger the town gets, you start committing to an assumption about how many security guards are you sure that you can that you're always going to have. Now, the good news about a blockchain here, right, is that with data availability sampling, every user of a blockchain is one of these guards, right? Every user is kind of randomly watching a random portion of this sort of metaphorical wall, and so every user is helping to check that like there aren't any unavailable like data chunks that are getting through. But like, whatever your scalability level is that you're committing to, you're also committing to saying we guarantee that we're definitely going to have at least 100 users, or say at least 1,000 users active at all times, right? So, like, that is an assumption, right? And the higher your scalability gets, the stronger that assumption gets. Like, once you start talking about blockchains that have like gigabytes per second, you're basically committing to saying, we are always going to have hundreds of thousands of active nodes. So if your chain suddenly becomes much less popular, that suddenly becomes a security risk. If everyone suddenly like switches to using more centralized clients, that's a risk not for them. That becomes a security risk for the entire network, right? So security just becomes more and more uncertain. And also your ability to guarantee the availability of history also becomes more and more uncertain, right? So like, for example, the Ethereum roadmap, right? It basically, the parameters that we have right now is, I think it was about 2.6 megabytes per second of blockchain data, I think. And 2.6 megabytes per second, there's 31 million seconds in a year. So that's going to be 90 million 90 million megabytes a year. So that'll be somewhere around like 85 terabytes per year. So like there's already that's like already a lot of terabytes that every year that are being added to the blockchain, right? And people have to store all of that. Now, if you crank that up by another factor of 100, then we're talking about like 8 petabytes per year, right? And so the higher and higher you go, the higher and higher the risk there is that just people are gonna like get tired of like all of this data, and you're gonna have an accident at some point, and you're gonna realize that like some piece of data from somewhere in history, nobody is storing it anymore. Now, I think 85 terabytes per year is totally fine, right? Like because 85 terabytes per year, like if you have even one person that just keeps buying like $100 hard drive, like I think once every month, then they can store it, right? Like it's something like that. So it's too big for just like a casual user that just wants to run the chain on their laptop, but one dedicated user who cares, like they can totally afford to store the chain. So 85 terabytes, not a big deal, right? But once you crank that number higher, there comes a point at which it starts becoming a really big deal. So I guess that like the answer is a little bit unsatisfying in that there isn't some point above which like it's obviously scalable up to this point, but it's obviously not scalable beyond this point. It's like there are these weird systemic risks, and as the scalability goes up, the systemic risks go up, and there just comes some point at which, it becomes harder and harder to argue that this is like a credibly 100% secure and reliable blockchain. But, do we know what that point is? Well, unfortunately, we don't really know until an accident happens, and so we have to be careful. And so, like, I think, like, I personally am convinced that, the 2.6 megabyte per second number is very safe. I'm even convinced that going up, like, another half order of magnitude, another order of magnitude is very safe, but, realistically, we do want to keep the numbers like on the lower side so that we can actually so that nobody feels uncomfortable. Like that's basically where the limits are at. But 2.6 megabytes a second is a lot, right? Like if we're talking about ZK rollups that implement full compression, 2.6 megabytes divided by 16 bytes a transaction, that's like 130k TPS. And if we add a decade of Moore's law, then we're talking hundreds of thousands of TPS. So that's just like enough to run most users' transactions. So I think with quadratic sharding we'll be fine.
So we've gotten through the merge and the surge, right? And we still have 3 other urges to go through.
Yes.
But okay, so the merge gives us proof of stake, basically.
Mm-hmm.
People know what that is. The surge gives us scalability. So we get massive bandwidth, massive throughput, particularly on rollups. So now we have scalability on Ethereum, and now we have proof of stake. What about the Verge? That's the next one on the roadmap.
Sure.
So what does that add?
The Verge is the introduction of Verkle trees, right? So Verkle trees are a replacement for the Merkle Patricia trees that currently store the Ethereum state. So the Ethereum state is this database of like all of the accounts, all of the smart contracts, all of the balances, all of the contract code, all the contract storage, everything that is remembered by the Ethereum blockchain that contracts and users and applications can access. And that is all hashed into this tree structure, right? And Verkle trees replace that tree structure. They replace the current hash-based tree with a Verkle tree, which is based on vector commitments. Now, you have to ask, well, what's the benefit of switching to vector commitments? The benefit of this has to do with this concept that I think I've talked about many times historically, which is stateless clients. So what is a stateless client, right? So today, in order to verify block N, you have to have the entire Ethereum state. And how do you get the entire Ethereum state? You have to either you fast sync and you download everything, or you have to download block N minus one, or you have to verify block N minus one, right? So in order to kind of keep verifying Ethereum blocks and stay up to date with the chain, you have to have this entire database locally. This database is big. It's about 40 gigabytes, I think, and it keeps on getting bigger. And if we end up massively increasing the gas limit, then it'll get even more bigger. So so what do stateless clients do? Stateless clients are basically let you say, what if instead of needing this entire database to verify a block, we're going to have this thing called a Verkle proof, which gives you only the pieces of the state that are read and written to and accessed in a particular block, along with a proof that proves to you that those pieces actually are correct, right? And so if you have that proof, then you can verify a block without needing any other information. So you can imagine this proof as being an extra couple hundred kilobytes. So there is the data. So there are the accounts, the code, and the contracts that are being read for that particular block. And then there are just these extra intermediate commitments. And this is another few hundred kilobytes. And those proofs, basically tell you that the data that is being claimed actually is correct. Now, technically, you can make proofs with Patricia trees, right? But the problem is that the proofs are incredibly big. We're talking more than 10 megabytes. In the worst case, we're literally talking about 400 megabytes. So it's a little too much for users to be able to actually verify. But Verkle trees, they use some fancier technology. And if you want to learn more about that technology, I wrote an article about it. The fancier technology of Verkle trees allows you to have these proofs that are much shorter and that are fast to verify. And so we actually can afford to have these stateless clients, right? So what is the benefit of stateless clients? Stateless clients basically let you just immediately step in and say, hey, I'm going to verify this block. You don't need to have the state. You don't need to have anything. Literally a fresh node can just swoop in and say, hey, I want to verify this block. And it can ask the network for the block, ask the network for the proof. And once it has the block or the proof, it just immediately sweeps through and it just verifies the whole thing. Now, why is that useful? One reason why that's useful is that it allows validators to be much lighter. Validators would not have to have this big, heavy database. Validators could just only verify blocks that they need to verify in real time, right? So as a validator, you would not need to have a big hard drive. You would theoretically be able to just do everything in RAM. So it will be scalable, faster, much easier to set up, much more convenient. So the experience as a validator would be much more decentralized. And all you would have to do is you would just have to verify these blocks with these extra proofs attached, and that would be all that you need to do to just participate in the network.
Well, so does this mean running a validator, running a node becomes so much easier on Ethereum so that somebody could run it on a phone, for example? I mean, there are a lot of
possibly, yes.
Right. So and this is a design for the decentralization of Ethereum, right? It's all of these urges have the same thing in common, which is scalability without sacrificing decentralization. That's what we're doing with the merge. And so if more people are running nodes, have the ability to run nodes, back to your point when you were talking about the Verge, this gives us more defenders of the city, basically. So now we have the ability to add more bandwidth and increase the population of our city because we have more defenders who are able to run nodes to verify that everything in the city is it's going okay.
Exactly. I guess one analogy might be that instead of having to actually physically get your armor and weapons and go to the wall to be one of these watch guards, you could just sit in the comfort of your home and you could just have a drone. And you just fly nice. Up the drone.
So there's a theme that I'm noticing so far is some of these updates, some of these urges are really about increasing scalability, and then some of these updates, some of these hard forks, these urges are also about making sure that those upgrades are secure. So one is upgrading scalability, and then the rest are making sure that that effort is safe. And the Verge really seems to be about democratizing access to the broadest number of participants possible to anyone and everyone who wants to verify the validity of the chain.
Exactly.
Would you say that's a fair summary?
Yeah, I think so.
Okay.
And then, of course, the desire for everyone to be able to verify the chain is that when everyone can verify the chain, you as an individual can't be bullied by someone that can propose blocks when you can only verify blocks. Cool.
Exactly.
This brings us to the fourth urge. This is the Purge. I think there's a popular movie with that title, but no relation.
Not a popular movie.
Okay, not a popular movie. Anyway, this is not at all related to that. What are we talking about when we are talking about the Purge here on Ethereum's roadmap, Vitalik?
Basically, this is about kind of eliminating the dead weight of history from Ethereum. Now, in a very broad sense, right? So there's different kinds of dead weights of history that we have to deal with. One example of that is just like the load of the historical chain, right? So today, a client joining the Ethereum network has to download all historical blocks. And they have to store all historical blocks. And this is a lot of data. This is like hundreds of gigabytes. And post sharding, it will be even more, it'll be terabytes. So the history expiry, this is that blue rectangle that's a little bit to the left. And by the way, in this diagram, time approximately is left to right. So I'm hoping that history expiry actually does happen only a little bit after the merge, right? We see how the history expiry rectangle is like only a little bit to the right of the merge. So history expiry, basically says we stop requiring all nodes to store all of these historical blocks. Instead, clients stop storing history that's more than 1 year old, and we kind of shift the responsibility of storing and retrieving that history to other protocols. So EIP 4444 is probably the most popular history expiry EIP right now. It's just very simple and dumb, just says clients don't have to store that stuff anymore. So I think the interesting question there is, if all client nodes do not have to store history anymore, then who does, right? There are applications that depend on history that are more than 1 year old. I mean, even rollups do, right? Like a rollup, in order to actually sync the state of a rollup, you do have to get data, either you kind of trust some state root that's say 1 week old and you have some separate peer-to-peer network that you download the state from. Or if you want to do it with just a blockchain, then you do have to basically walk through the entire history of the rollup, and so you do have to process all of these blocks one by one, right? A lot of applications depend on old history to tell you about all instances of when you use that application. So I'm not sure exactly how DAI and RAI and all these things work, but maybe you need to scan the history to tell you what all your CDPs are. I know Augur needed to use historical logs to tell you all of the different markets that you've participated in. So there is a lot of value in history for at least some applications. And so there's this interesting question of what are these alternative ways of getting history, right? Now, the good news is that history is the sort of thing that is very self-verifying, right? You can just give someone Merkle proofs and they can verify Merkle proofs. So it's not super hard to create protocols that kind of replace the Ethereum blockchain in actually giving users this data. And the other really nice thing about historical data, right, is that it is a one-of-n trust model. So I think in one of our previous episodes, right, we talked about trust models. I wrote this post on trust models and the difference between n out of 2 of n, 1 of n, 0 of n. And the big difference between consensus and history is that consensus is an n out of 2 of n trust model, and so we have to worry a lot about it. But history, data grabbing, is only a 1 of n trust model, and so it's something where we actually can breathe a little bit easier, and we don't need to require everyone to store everything, right? So the main contenders for getting history data, one is obviously the centralized approach, right? Etherscan, Etherchain, Beacon Scan, Amber Data, all of these lovely folks, they are going to keep storing the entire chain because their users want the chain. And so if all else fails, there are these like about half a dozen centralized backstops that you can go talking to. Decentralized protocols. The Portal network is the Ethereum Foundation supported kind of protocol for doing this. Basically, every node would only need to store a small percentage of all the data, and you would have a network that would just automatically route users to the subset of nodes that store like one particular piece of data. So one simple mental model for thinking about this might be that, like, when you start up your node is just going to pick a random number from 0 to 100, and let's say your node picks the number 67. And then your node is going to just agree it's going to store the entire history for all blocks whose block numbers end in 67, right? And so if a user needs a transaction from a block whose block number ends in 67, it's going to talk to you. But instead, if a user needs a transaction from a block whose block number ends in 45, then it's going to talk to David instead, right? And you have networks like the Portal network that just automatically make all of this happen. So that is the roughly what the Portal network is going to do. There are also third-party protocols, right? So the Graph is one that I think is very far along in doing this sort of stuff that a lot of people are excited about. The Graph is a protocol that a lot of applications are switching to already, right? So a lot of existing applications, they stopped using Ethereum native, like history and log grabbing because it was too slow, and they switched to the Graph because it's faster, right? And so the Graph already provides a lot of this. Now, the Graph is not yet fully decentralized. The Graph still has a kind of training wheel, some centralized trust built in, but they do have a roadmap for kind of taking that out over time. So the Graph is another option. There's another option is also light client protocols, right? So light clients protocols, well, I think eventually they are going to end up kind of plugging into the Portal network, but there's a lot of work happening with light client protocols. So light client protocols are going to become much easier as a result of the merge, because the merge supports sync committees, which make running a light client much easier. And so we'll have a lot more light clients, and we'll have a lot more of this Merkle proof grabbing infrastructure. So the summary, right, is that the Ethereum base protocol will stop forcing every node to store all of history, but instead there's like this entire array of alternative solutions, centralized solutions like block explorers, the Portal network, the Graph, and even more protocols that I've forgotten about. All of these different alternative solutions that clients will have to instead go to if they want really old history information. Now, remember, most applications don't really even need old history information. So this is like for that subset of the applications that do, there are these solutions. But for users that don't, then, Ethereum will just keep working exactly the way that Ethereum works today. So that's history expiry. The longer term one that we could talk about next is a state expiry, right? So history is, like the analogy for history and state that I talk about often is, like history is, or the state is like a country's record of who its citizens are. History is like all the birth records and all the death records, right? So it's obvious that history is bigger than state because, like, when someone dies, they get removed from the state, but they're still part of the history. And then an archive node is like a node that stores, like, basically that has a separate page storing, like, who the citizens were during every possible year in history, right? So now, obviously, if you have the history, you can use that to regenerate an archive node. And if you have the history, you can kind of play through the history, and you can use that to generate the current state. But the history is bigger than the state, and the archive node data is bigger than the history, like much bigger than the history and the state. But you can regenerate it from the history. So the state expiry basically says, well, even though the state is smaller, eventually the state is still going to get really big. And so what we're going to do is we're going to say objects in the state that have not been touched for the last year are going to go into the separate expired tree. And the Ethereum protocol is not responsible for storing the expired tree. The expired tree is part of history. But if you care about some account or some application that got moved into the expired tree, you can go and provide the Merkle proofs, and you can revive it. right? So state expiry does not impose on anyone like a risk of, their coins getting deleted if they accidentally go into a cave for 2 years. Like, if you go into a cave for 2 years, then you're just going to have to provide the Verkle proofs to recover your coins, right? Which is something that you totally can do. But in order to do that, like, you're not going to be able to just go through the regular Ethereum protocol. You're going to have to like talk to the Portal network, or talk to the Graph, or talk to a block explorer, or talk to one of these other people in order to actually get that data. So state expiry is actually something that I think can wait a very long time. So you can see that in this diagram, it's the rectangle is like far to the right of even all of the other rectangles. One of the reasons why it's so far to the right has to do with something that we'll skip briefly ahead to the Splurge, proposer-builder separation. This is this buzzword that I think has become very popular over the last few months. This is basically this idea that the validator that proposes a block and who actually constructs the block do not have to be the same actor, right? And instead of forcing validators to create blocks, we're going to have an auction, and we're going to auction off the right to create the blocks. And the reason why we're doing this is because creating a block that like really gives us the highest, gives the creator the highest possible fees, gives them the highest possible MEV, gives them the highest possible revenue, in the long term is a pretty hard problem. And we don't want to force validators to have to like figure out the complexities of dealing with that problem, because we want anyone to be able to be a validator. And so instead, we're just going to say that there's a separate class of actors they're going to create these blocks, and there's going to be an auction. And so proposers can just easily choose the block that pays them the most. And we'll add some extra protocol armor to ensure that this whole thing is still censorship resistant, that transactions can still get in. There's like Dankrad and our friend Francisco have been doing a lot of research on that. But one of the really nice side effects of PBS is that validators are no longer involved in the job of creating blocks, right? So validators no longer have to store the state. This also gets into Verkle trees, right? Validators only have to verify blocks. It's the builders that have to create blocks. So the builders have to store the state, but the builders are going to be pretty specialized anyway. And so if the state blows up to 4 terabytes, well, the builders can store 4 terabytes, right? So if we have Verkle trees and we have PBS, technically we don't really ever need state expiry. And so if the can gets kicked down the road 20 years on state expiry, that's actually totally fine. But like, I think eventually we do want the Ethereum protocol to be kind of more elegant and to not have this kind of extra junk data that keeps going up and up forever. And so adding some kind of state expiry does make sense, right? So that is like a much longer term thing. But if it has to happen, it can happen. And then the last part of the purge has to do with technical debt, right? So it has to do with actually simplifying the protocol, and actually removing a lot of the complexities from the code that currently make it more difficult to create a node, that currently make it more difficult to actually run a node, to debug, and to just make an Ethereum implementation. So the self-destruct opcode is one of those opcodes that I really hate, and that I have good reasons to hate. I think if you just Google search Vitalik bans or Buterin ban self-destruct, you can probably find the post where I advocate for why we should ban self-destruct. Oh no, sorry, it's Buterin pragmatic destruction of self-destruct. That's the title. So I talk about why I think that's a good idea. Verkle trees also depend on banning self-destruct because they change the storage layout in a certain way. Gas stipends are another thing that I want to remove at some point. A lot of the precompilers we can remove, and we can just replace them with EVM implementations. We can simplify logs eventually. We can remove RLP eventually. We can find solutions for dust accounts. So if someone has say $50 of ETH or $50 of ERC20 tokens today, and they have a hard time paying the gas fees to remove that, then there are a number of ideas that can make it cheaper for them to deal with all of that stuff. So a lot of little things, right? But the core idea here is to basically kind of leave the past in the past and create an Ethereum that actually becomes simpler and simpler over time.
So I want to try and summarize that using a metaphor and see how well that lands with you. And so my mind is actually going to the game of Snake. Once upon a time, the game of Snake was played with little squares. And the snake, you would start off really, really short. Maybe it'd only be 4 or 5 blocks long, and it would move around the screen and it would eat a block, and then it would grow 1 block longer. And that's kind of like a blockchain, right? Blockchains grow, people add data to them, the snake gets a little bit longer. And as that snake gets longer, it also gets harder to manage, and sometimes it runs into itself and dies. I actually think this is a really good metaphor for a blockchain. What you're saying with the purge, is there, and if ultimately, the game of Snake ends with you dying because you got too long. That's the long-term conclusion of the game of Snake, and hope maybe also the long-term conclusion of blockchains. Maybe if there's too much data in a blockchain, it just gets too long and then it dies, it crashes. And so what you're saying with the purge is there's a bunch of ways where we can start to trim off the snake and keep it shorter, keep it more agile, keep it more lightweight. And when it's shorter, more people can manage it, more people can use it. And so state expiry, history expiry, and then just eliminating some of these EVM opcodes and some other things are all different ways that we have determined that we can safely trim off the tail of the snake and leave what you said, the past in the past. So that the snake stays at a manageable length that could be managed by more people. How is that for a metaphor?
That is a really fun analogy.
Cool.
Okay, let's see if I can come up with a city analogy for the purge. Let's say imagine you have a city, right? And let's imagine that because of global warming, every couple of years you just have to move the city 100 kilometers north, right? Because the earth is warming, and so eventually where the city was before, it gets too cold. Now imagine if you have for some reason, today, we just designed the city kind of security protocol in such a way that even though the city keeps moving and we have to keep building new city walls, we still have to keep on guarding all of the old city walls forever, right? So every time there's a new city, the number of walls that you have to keep guarding just keeps increasing, even if the city's population doesn't go up. Right? So the purge basically is about fixing that problem and about saying hey, these cities are abandoned. And, if you really want to, go and grab stuff from your old home, then, we can, provide you for some way to, hire some private security so you can go and visit that city. But, we're not going to keep maintaining security for that city forever.
And then on theme with what's been going on so far is with first some of these changes are Ethereum expanding and growing into new fields, and then some of these changes are Ethereum protecting that expansion. Right, first we build out and then we harden. And so
exactly.
One of the questions I had for you is that we're eliminating state in Ethereum was part of the purge, which is kind of antithetical to what a blockchain is. Blockchains, you're not supposed to eliminate data. That's not what they do. In fact, it's actually quite the opposite. But what you're saying is, with some of these strategies, we can safely prune some of the data and have strong assurances that data will still be available somehow, some way, by some manner, in ways that it feels still secure to eliminate that data from the current state while still having strong assurances that data is available somewhere.
Exactly. So, the way that I think about the blockchain philosophically is that it becomes this kind of public billboard, where the billboard guarantees that everything that looks like it's on the billboard actually was published to the billboard and it actually was correct. But you don't actually have to have everyone that's responsible for securing the billboard also be responsible for recording the entire history of the billboard, right? Because, recording history is an easier problem than securing. And so, we only have a smaller number of people actually record the history of the entire billboard, and that smaller number of people is enough because securing the billboard is an n out of 2 of n problem, but recording history is a 1 out of n problem. And so we just don't need to have this incredibly huge number of people recording the history of the billboard forever.
There we go, guys. Isn't blockchain fun? Snakes and cities, merges and purges. Here we go with the fifth one, is my favorite, at least in title, is the Splurge. Let's talk about the Splurge. And there's so many things I think we could talk about, because this seems like almost like a grab bucket category, miscellaneous category of all sorts of other cool things that Ethereum could do in the future. Maybe some of these things are further out than others. But could you pick maybe 1 or 2, Vitalik, that you think would be useful to talk about in this catch-all bucket?
Sure. Proposed builder separation we've talked about already. Account abstraction. That's one that we've talked about, I think, since forever, and I think people have heard about that at a long time, right? Like, basically, the idea is just like make smart contract wallets more like first class citizens, and so it becomes as easy to like do all of your Ethereuming with a smart contract wallet as it is with a regular account. And today that's not the case because of the way that the Ethereum protocol was just structurally assumes that everyone has what's called an externally owned account. But account abstraction just fixes those issues, and so things like multi-sig wallets, things like social recovery wallets, just become really easy for anyone to use as their primary account. So I think the newest development in account abstraction is ERC4337. So this is a layer two sort of approach to account abstraction that says instead of changing the protocol to support account abstraction, we're just going to create this kind of second transaction layer where we have these user operation objects that directly talk to smart contracts. And then there does need to be like a wrapper transaction that wraps around all of the user operations that get included in a block. But instead of having the transaction overhead per user operation, you just have it once per block, right? And then you have a separate mempool for user operations. Miners can listen to that mempool. Actors like that participate in flashbots can listen to that mempool. And so, like, basically you create this kind of like higher level ecosystem where users can do everything that they need to do with these smart contract wallets and with these user operations. There is this kind of higher level construction consisting of these actors in the ecosystem that are listening to this mempool that actually make sure that everything gets included on chain, right? So it's like, instead of changing the existing protocol, you create a protocol that sits on top of the existing protocol. So instead of layer 2 for scaling, it's sort of layer 2 for account abstraction. But like the difference here, right, is that like this isn't creating like a separate universe that's account abstracted. Like account abstracted wallets will be able to interact with all existing applications. They are Ethereum addresses, they are Ethereum smart contracts, right? So account abstraction, and like another really nice thing about ERC4337 is that the exact same ERC4337 can work on Ethereum layer 1, it'll work on Optimism, it can work on Arbitrum, it can work on Polygon, could, I think, with some modifications, work on Starknet. Like all of this, so it basically is this kind of path toward an ecosystem-wide upgrade that could bring us toward smart contract wallets actually being a reality.
That's very cool. Hey, can I ask the other thing in this grab bucket? Maybe there's so many other things we could talk about, but ZK snark everything, ZK snarkifying everything. That might be a bit more on the distant horizon, but that sounds really awesome. What is that?
Basically, we want to completely move away from this idea of like users verifying things by re-executing them, right? So like ZK snark the EVM so that users don't even have to don't have to run the EVM. ZK snark the beacon chain transition so that users don't have to run the beacon chain transition. ZK snark signature verification so users don't have to verify signatures. Right, so basically get to the point where the only person who needs to actually run the EVM and actually like run the beacon chain like state transition function and run any of that stuff is whoever is creating the block. Everyone else just verifies one snark, and that one snark lets them verify the entire block.
And so what does that give us? Like, does that provide dividends across all of these things?
That makes it extremely easy for anyone to run a node.
So it just adds more and more drones, watchtowers of all types to the city so that everyone is participating in the security of the city in an easier fashion.
Yep.
Cool.
It chops the snake's tail off, David. So it's just a little snake again.
So it's a single block snake.
So like all you have is like the head of the snake, and instead of the body of the snake, you just have like a ZK snark of a body of the snake, and like the snake is happy. It doesn't need the body. It just has a proof that the body exists.
Oh
Right.
my God.
Right,
Someone's
okay,
gonna make.
wait, I want to unpack that. So there's just one head of the snake, which is normal, and then the whole rest of the body has been ZK snarked. So it's this tiny little tail that's connected to this normal sized head, and that's how Ethereum just becomes super ultra lightweight.
Exactly.
Neat.
Somebody's gonna make a ZK Snark game in ZK,
Yeah.
Stark technology somewhere after this episode, I think.
The Gemini exchange has been my exchange of choice ever since I got into crypto. I use Gemini to both buy the dips and also manage my regular automatic monthly purchases of my preferred crypto asset. On Gemini, you'll find over 50 different cryptos, including many of the top DeFi and metaverse tokens like YFI and Axie Infinity. Using Gemini Earn, you can earn yield on your various cryptos, including 8% on the GUSD stablecoin. Gemini is available in all 50 states and more than 50 countries worldwide. So if you're looking to upgrade your crypto exchange, sign up at Gemini with gemini.com/gobankless and get $15 of Bitcoin after you trade $100 or more within the first 30 days. That's gemini.com/gobankless. Slingshot is a decentralized trading platform that combines the performance and ease of a centralized exchange with the openness and transparency of DeFi. Slingshot aggregates liquidity from all of DeFi in order to find the best price on thousands of crypto assets. Every token on Slingshot comes with a price chart and trade logs to give you insights into the market's activity in real time. Slingshot is available on Polygon, Arbitrum, and Optimism, saving you from the high gas fees and low transaction speeds of the Ethereum L1. There are no fees to trade on Slingshot, and any positive slippage is given to the users. Trading on Slingshot is a social experience. You can even set your chat avatar to your favorite NFT, or soon a Slingshot 2099 NFT avatar. Once you bridge your assets to Polygon, Arbitrum, or Optimism, go to app.slingshot.finance to trade and use the chat box to share your trades with others and find other tokens to ape into. The Brave browser is the user-first browser for the Web3 internet, with built-in privacy and ad blocking to keep you in charge of your digital footprint. Inside the Brave browser, you'll find the Brave Wallet, the first secure crypto wallet built natively inside of a Web3 crypto browser. Web3 is freedom from big tech and Wall Street, more control and better privacy. But there's a weak point in Web3, your crypto wallet. The Brave Wallet is different. Brave Wallet is built natively inside the Brave browser, no extension required, which gives the Brave Wallet an extra level of security versus other wallets. With the Brave Wallet, you can buy, store, send, and swap your crypto assets, and you can even manage your NFTs and connect to other wallets and DeFi apps, all from the security of the best privacy browser on the market. Whether you're new to crypto or a seasoned pro, it's time to switch to the Brave Wallet. Download Brave at brave.com/bankless and click the wallet icon to get started.
Vitalik, give us kind of the high level overview. So we started this episode. You said you felt like you could be convinced in saying that Ethereum is maybe 50% of the way done. Okay. Mm-hmm. Does the end of these things after the merge, surge, purge, verge, splurge, are we at 100% at that point in time? Is everything done?
I would say so. I mean, there are a couple of these longer term extras that we haven't talked about, but it would probably take too long for us to talk about all of them. But I feel like, and I do think that like, none of these roadmaps are final, right? Like these roadmaps are kind of my attempt to reflect the current rough consensus of the research team. So like there are new things that did not exist before, right? Like PBS did not exist a year ago, and so you did not see PBS in last year's roadmap. So there might be a couple of things, but I think once all of these things are done, like I will say this. If this is all done and then nothing else ever changes after that, then I'll be extremely happy. Right? Now, like, I feel like this covers everything that's, like, necessary for Ethereum to not only survive, but even thrive going into the long term.
So Ethereum is... I was just going to ask as well the timeline. So Ethereum is 6 years old. How long is this going to take? Is this going to take another 6 years?
I could definitely see all this happen in 6 years. Yeah.
Mm-hmm. Vitalik, is if one or a handful of these things doesn't happen, is everything here crucial? Does everything here need to happen in order for Ethereum to last multi-generations?
I would say if only the merge and the surge happen, then Ethereum can already survive and thrive and last multiple generations. To me, again, it's possible that PBS is necessary for security, and it's like possible that the Verge is going to become really important eventually, but even there, it doesn't need to, right? Because, one possible alternative to the Verge is that eventually if the merge and the surge finish, at some point we just reduce the gas limit all the way back down to 3 million, because we don't need layer 1 gas anymore because everything happens on layer 2. right? So aside from the merge and the surge, there are alternatives to everything, but I think it is still a nice to have. And so, I'm still really excited about all of these things taking place.
And so what we're looking at, guys, is for Bankless listeners, we're breaking into kind of the firmware, the machinery of this trust computer that we call Ethereum here, right? Like that's what we're doing. We're kind of almost looking at the motherboard with Vitalik, if you will. Once this computer is built, and of course, I know you remember Vitalik, the meme of Ethereum, the internet computer that went a little wild in 2017.
No, the world computer, the internet computer.
Yeah, excuse me, the world's computer. That went a little wild in 2017. But like, there's some truth to it, right? This is a world computer that has been built. So once this roadmap comes to fruition, what will we have? Like, what is at the other side of this? I mean, Bitcoin's vision famously is now become sort of a digital gold, if you will. It's all about Bitcoin, the asset and the scarcity of that asset. What do we get when this world computer is fully built out?
When you'll get a system where if you want to build an application where you want some piece of that application to have execution that's globally trusted, you can just use Ethereum to do it.
And that spawns, infinite numbers of possible applications, some of which we have designed so far and some of which I guess we'll see in the future.
Indeed.
So Vitalik, that was a high-level summary of the Ethereum roadmap thus far and into the future, even though it's a always changing thing. The crypto industry is always changing. And something that we've seen in the last year is the rise of the alternative layer ones. And where Ethereum has this goal to get to the state that we've been discussing, alternative layer ones have cropped up, some with different goals and some with other goals. And you've also written an article lately called Endgame that makes the case that all blockchains ultimately converge on the same future. And so we want to unpack this part of this conversation because other alternative layer ones have their own roadmap, and you think that ultimately long-term blockchains will converge upon the same future. So we want to unpack that. But before we get into the Endgame article, I just kind of want to get your take on 2021 with regards to Ethereum and then all the other smart contract platforms that came about. The first half of 2021 was really just Ethereum's show. NFTs absolutely blew up. DeFi was huge. We saw the seedlings of Web3 platforms put cryptography into corners of the world that had never seen it before. So many people got private keys. So many people learned how to use MetaMask. So many people approached crypto in a positive light rather than just drug dealing internet money, which was really cool. And Ethereum in the first half of 2021 kind of turned into a victim of its own success in my mind. It got so adopted so quickly that it became extremely congested. Just massive adoption turned into exclusionary gas fees, expensive NFTs priced out everyone. And Ethereum kind of got this negative branding as like a whale chain, if you will. And this turned into a bunch of pushback into alternative newer layer ones and pushed users into these newer layer ones because crypto people want to do crypto stuff. They want to push buttons on their MetaMask. They want to push buttons on their ledger. And so we saw the rise of Binance Smart Chain, Solana, Avalanche, Phantom, Terra, just a slew of other layer ones to really satisfy the demand of layer one block space. And so I don't really have a specific question here, but what do you make of 2021 and the distribution of where the average crypto user has fallen with regards to all the different new crypto systems that are out there? What do you make of all this?
Yeah, and I think there's clearly a lot of demand for scaling. There's a lot of demand for blockchain space that is cheap. Like ultimately users are going to gravitate to where that space is provided, right? Actually, this reminds me of fun fact from my recent trip to Argentina. So guess what is the alternate layer one that people just like using cryptocurrency on the ground for commerce in Argentina are using most often, that as far as I can tell.
Bitcoin?
No, Bitcoin's also expensive, right?
Oh, okay.
It's one where transactions are extremely cheap.
Okay, well, let's go through it. Is it Matic?
No.
Is it okay? Not Matic. Is it Terra?
No.
Solana?
Wait, I think you might be
No.
right, Ryan. I think it's Tron.
Binance? Is it going to be Tron?
Okay. Tron is probably one of the number two. Like, what's the number one?
Binance Chain?
It's Binance, not Binance
Binance.
Smart Chain.
Binance
Binance
itself.
Decentralized Exchange.
Okay. Wait,
Yeah.
for like for doing what? What are they doing on Binance?
Like they just like need cryptocurrency for payments.
Yeah.
Like one of them was just a coffee shop that accepted crypto. There are a couple of other businesses. Like when I ask if I can pay with ETH, they just show me the QR code of a deposit address, and like it's just obvious that they're used to like Binance to Binance transfers, which are instant, right? And like my Ethereum to Binance transfer has to wait for 12 confirmations in the app. So. Yeah, there we go. That's, so far that's the Ethereum killer.
So is Binance like an alternate layer one in your mind, or like I've always thought
I
of
mean,
like Binance
ultimately it
as
is, right? Like,
guess
sure, it's
so.
like a guy's database, but if we're talking about people who don't care about the level of decentralization, then like, that's what they're,
So just to illustrate this, if you have a Binance address and I have a Binance address, both Binance knows that it has both of our addresses. And so if it goes from Binance address A to Binance address B, it just accounts for that on its internal ledgers and just updates its internal balances. And the users are apparently okay with that in Argentina.
Exactly.
And they should be, because like it's better than the existing system, which is what makes them users, right? But
yeah, like I think like in Argentina, I remember that the thing that all of this crypto stuff is competing with is one, like highly inflationary Argentine pesos, and two, US dollar cash, which is inconvenient. You have to hide it under your mattress and potentially have it get robbed, or you have to put it in some complicated safety deposit box that you have with like some company that you have to maintain. So like even Binance Decentralized Exchange is already a big improvement over what these people would be using otherwise. Now, obviously, ideally, the Ethereum ecosystem would be able to serve all of these users directly, but scalability is not high enough for that yet. But it is, as I think we've talked about, it's coming quite close to being ready.
So are you making the case, Vitalik? I want to make sure I understand. So like, do you think it's true that users don't care about decentralization, or like, why should they even care about decentralization if Binance is going to service their needs and provide what they need? And, maybe I, as someone in Argentina, would you trust CZ and Binance over my local banking system? And I understand why. Are you making the case that that's true, and that therefore some of these alt layer ones that trade off decentralization for bandwidth and speed and that sort of thing, that's a good thing? What are your thoughts there?
I think a lot of people do care about decentralization, but like they're not going to take the decentralization if the decentralization costs $8 a transaction.
There's this quote that you had in 2017 that says the internet of money should not cost 5 cents per transaction. And I remember when you said that in 2017, and I think a lot of people who have been angry at high gas fees on Ethereum have used that quote recently. Let me ask you, do you still believe that?
Of course I do, yeah. And
well, talk about that in the context of the Ethereum roadmap.
Yeah, I mean, I think, in order for blockchains to be able to actually be something that, like, people are going to adopt for just mainstream applications, like, it has to be cheap. And it has to be not just cheap by the standards of whales who bought crypto in 2014. It has to be cheap by the standards of people who are coming into the system today and who are going to be putting, $20 or $40 into crypto if they put in anything at all. Right. And so Ethereum Ethereum today is not the layer one is not a system that's ready for direct mass adoption by users. But that's exactly why we've been harping the drum of scalability and layer twos and sharding and all of these things since 2014. Right. The Ethereum's roadmap, and kind of vision and strategy is exactly the same as it was back in 2017 when I talked about the need for fees to be low. The layer twos are coming close to providing that, right? Like Loopring has been around for a year and it provides, transaction fees that are not quite 5 cents, but they tend to be around 15 cents or so today. And of course, once sharding comes along, then like it will be much less than 5 cents again. So there's like the layer 2 ecosystem is definitely together with layer 1 sharding is completely on the way to like bringing us back to the really low fees that we had back in 2014 and 15, and that allowed so much amazing experimentation early on to start happening. But to get there, we do need to actually solve all of these hard technical problems.
There's a line that's going around in the crypto Twitter sphere and the overall conversation of all the crypto people out there about how Ethereum maxis are just Bitcoin maxis 2.0. And it's unknown whether this trope is actually stated by the users or perhaps injected by the VC L1 builders out there trying to FUD Ethereum. Perhaps the truth is somewhere in the middle. But Vitalik, as somebody who originally forked off of Bitcoin, how do you feel about that line?
I definitely think that maximalism is something that's very unhealthy. And like there definitely are tendencies, I think, among some people in even the Ethereum community to try to kind of brand everything outside of the Ethereum ecosystem as being boring and illegitimate, which like I don't think is true. Like I think, there's real fun, like interesting stuff happening in Zcash lands. There's real interesting stuff happening in like say Tezos. There's one of the cities that I talked about in my Crypto Cities article, they're doing everything on Tezos. So they're like, I do think that, there are honorable communities that are not just like taking the quick buck and that actually do care about decentralization. But at the same time, right, like it's also like there's definitely a lot of people that like basically just use the word Ethereum maxi to just refer to someone who supports Ethereum, which is just crazy, right? Like there's like this idea that like decentralization is really important, for example, right? And I think Ethereum is like one of the really valuable and important things about the Ethereum community is that it does have a core that strongly believes in decentralization. It's willing to continue fighting for it. It's willing to like even delegitimize and stop publicly supporting applications that kind of betray those principles. Yeah, whereas, on a lot of other ecosystems, like you have entire dApps that are like closed source and people just like barely blink an eye about it. So that's so I think, I guess my view there is somewhere in the middle. Like, I think it's definitely important to like also have our eyes open and look at look at what's going on in all of these other ecosystems. But at the same time, like we do have to remember that a lot of people do like support Ethereum not just because of some kind of like bias of like they got their bags in earlier, because like ultimately like if you have your bags in Ethereum but you decide Ethereum is worse, then you can just move all your bags to something else. It's a free market. But I think people do believe that decentralization is valuable and important, and they see the Ethereum community as being a community that is willing to actually work hard and take all of the necessary steps to actually build the future where we have scalability and decentralization at the same time. And that's, I think, something that's really important to keep.
And I know you personally, Vitalik, aren't maximalist about anything. Read your article about concave versus convex thinking, right? That sort of thing. But if you had to be ascribed the label of maximalist something, would you like, how close are you to being a decentralization maximalist?
What was that again?
How close are you to being a decentralization maximalist? Does that describe your philosophy on things, Vitalik?
I mean, I would not call myself anything maximalist, but I definitely think that decentralization is extremely important. It's like ultimately decentralization is what this space is about, right? And then, like once you start compromising on that, then there does come a point where you just have to ask, well, like what is even the difference between what's being built here and centralized systems? Like I think the more that we can actually get to like genuine decentralization and an ecosystem where, in order to make changes to the protocol, like it actually needs to have buy-in, not just from a couple of protocol elites, but from the entire user community. Like, I think that's a really important and beautiful thing. And it's also an important and beautiful thing for, ETH, the asset, to maintain its credibility. It's an important thing for a lot of the applications on Ethereum to maintain their credibility. And it's something that we need to fight for and support.
This starts to get into the conversation of the Endgame paper, which I think we want to transition into now. And I think I do agree with you, Vitalik, that obviously the decentralization is the prime thing that we are that really supports this entire industry. But a lot of the alternative layer ones that have cropped up in the last half of the year have penetrated into the crypto markets using cheap block space fees, having ample block space supply, and they got that way via centralization. But there's an argument out there that says that while Ethereum sacrificed scalability first in order to achieve scalability later, other centralized layer ones sacrifice decentralization first and can achieve decentralization later. It's just a matter of picking which of the blockchain trilemma systems points do you want to compromise and then work on. So I want to get your perspective on if you think that's a fair characterization. Can you compromise on decentralization at the start to achieve it later? And do you think all of these alternative layer ones, all layer ones, all blockchain layer ones ultimately converge on more or less the same design structure in the very distant long term?
I mean, first of all, I think this post is in some ways more about the theory than the practice, right? Like, in practice, I think a lot of these communities pay lip service to decentralization, but they don't deeply give much of a crap about it. Like, how many of them even try having multiple clients, for example? Some do, right? But others don't. And I think looking at which ones do and which ones don't tells you a lot about an ecosystem. So the question I asked basically is if you were to say put me in charge of one of these centralized big blockchains and I were to and you were to ask me what would it take to actually turn that chain as it is today into a blockchain that has what I would consider to be acceptable levels of decentralization and trustlessness and censorship resistance, right? And the plausible roadmap that I have here basically has a collection of things that a big blockchain can do, in basically to add what I would call protocol armor that actually adds censorship resistance and decentralization. So,
which was a big part of the conversation of the Ethereum roadmap that we just had.
Exactly. So the core ideas here basically say, well, okay, look, we have this chain where block production is very centralized, but what if we can allow block verification to happen in a way that is decentralized, right? So you have all sorts of decentralized actors that can propose transactions where those transactions have to be included, and so you have censorship resistance, and then you have all of these different actors actually do the verification so that a bad block producer or a bad collusion of block producers can't actually push an invalid block through, right? So I talk about having a second tier of staking with low resource requirements that does some distributed block validation, and so you can do some committee verification. You can also do verification with ZK snarks or verification with fraud proofs. To check that block data is available and that blocks aren't being hidden, you can introduce data availability sampling, secondary transaction channels, so different ways for transactions to get seen by these second tier stakers, so that the protocol then actually forces the creator of the next block to include them. So all of these kind of pieces of armor that you can add around a protocol, so that even if you do have one big block producer, what they produce is still validated by this highly distributed process that prevents them from actually using their power to do anything terrible. Right. So this is the best that you can do if you want to start from where these blockchains are today and get to a point that I would consider acceptable. So
just to iterate, this is a strategy for crypto systems that have compromised on decentralization, and they have centralized just a small handful, maybe just even one block producer, one entity or a very small number of entities that actually produce the blocks. But what you're saying is there's a series of technologies that allows for the individuals, the many of the world, to check the powers of that central party. So while that central party does have a lot of power because they're the only ones proposing blocks, or maybe there's just a few of these block proposers, they still have to pass through the many, many, many individuals that are given power, given sovereignty through some of these cryptographic techniques. Is that what we're saying?
Mm-hmm.
And what kind of system do we end up with if they did that, Vitalik? Is this what we mean by decentralization? So like,
Yeah, well,
what sorts
right.
of things could the block producers, have power over, and how could the verifiers, the validators, sort of provide a check on that power?
Right. So the worst that they could do, like one is they can extract all the MEV. They could probably delay all transactions by a couple of blocks. So like we have a lot of this research on these alternative transaction inclusion mechanisms that can force transactions to be included, but those mechanisms aren't perfect, and they eliminate a lot of the block producers' power, but they don't eliminate all of their power. So block producers would still be able to like manipulate ordering of transactions a little bit. If like you have an NFT auction suddenly appear, then like the block producers would still be the ones that will be able to get first dibs on everything. So it's not perfect, but it is still a system where like you can't push invalid blocks through, you can't completely censor transactions, you can't push unavailable blocks through, and so the core things of what a blockchain needs to be a blockchain theoretically are still there.
So one of the questions I have for you, Vitalik, is there are some parallels here, and this is next up in your article. There are some parallels between centralized L1s with centralized block producers and layer 2 rollups on Ethereum. Can you elaborate for the listeners as to why so much of these conversations overlap between centralized L1s and L2 rollups?
Sure. So this is the second thought experiment I have here, right? Which is like, imagine if we do layer 2 scaling, and there is one rollup team that does a really good job of engineering, and they get really high levels of scalability, right? So like imagine Arbitrum, for example. They have an amazing EVM ZK rollup, and they figure out how to do parallelization. They figure out how to do like an amazingly parallel EVM. They have a super high performance node, and they have a rollup that does 10,000 TPS. Right. Now, the techniques for how to do this are pretty well known, right? Like Dan Larimer and EOS has been talking about this stuff since even 2014, right? Now, imagine if you have this system and you have this as a rollup running on top of Ethereum. What does that world look like, right? So I would argue that world actually looks extremely similar to the world where you start with a centralized chain and you add the protocol armor. The difference is that in the centralized chain, like you have the centralized chain that does the centralized sequencing, and then it also adds the decentralized validation. In this world, you would have Arbitrum or the Arbitrum sequencer, whoever that is, do the centralized sequencing, but then you would have the Arbitrum protocol fraud-proof functionality that allows the decentralized validation to happen, and then you would have the Ethereum protocol itself provide all of the protocol armor to keep the rest of the decentralization, right? So like, for example, you would need rollups already. They generally have secondary transaction channels. So if the main sequencer is not accepting a transaction, you have an alternative way of getting your transaction included, and the next rollup block is forced to include that transaction. You also have data availability verification is done by the Ethereum protocol. So today everyone downloads everything, but in the future we have data availability sampling. So the Ethereum protocol becomes this kind of guarantor of censorship resistance and availability, and all of these other things. And then you have in this case the Arbitrum smart contracts that would actually provide the fraud-proof verification and a lot of the rest of the armor that makes sure that whoever does create the blocks can't actually abuse their power, right? So even though it's implemented using a very different path, and you have this different kind of division of labor between the Arbitrum Layer 2 protocol and the Ethereum Layer 1 protocol, the result actually still ends up looking fairly similar to what we had in the first section there.
So that's the second thought experiment, and we get sort of a similar result, similar endgame, as the title of the article says. But that's probably not what we expect, or at least most in Ethereum right now expect. We probably aren't going to see one rollup dominate and win. That's a possibility, but we probably won't see that given the plethora of different rollup solutions, implementations, trade-offs that they're making, and strengths that they have. What we'll probably see is a multi-rollup world where we have many different rollups from many different teams. But you make the argument in this third thought experiment that even if we have a multi-rollup kind of world, if we live in that world, we might still end up in the same place. Can you walk us through that piece of things?
Sure. So this gets us into this discussion of cross-domain MEV, right? So the issue here basically is, okay, you have many different rollups, but even if you have many different rollups, there's this argument that there is an incentive to try to be a block producer on all of them at the same time. And the reason why there's an incentive to be a block producer on all of them at the same time basically has to do with this concept of cross-domain arbitrage, right? Like, if you scroll down to that diagram, like, this is an, up, the Western Gate one. Yep, the purple, yeah. Like, this is, cross-domain MEV opportunity discovered by Western Gate, right? So you're converting 44,374 USDT into 44,660 USDT, and half of the operation happens on, I think that's Polygon, right? And then the other half of the operation happens on the Ethereum base chain. So as we move to a layer 2 centric Ethereum, things like this will become normal. It will become normal to see that, like, there are these arbitrage opportunities where one half of the opportunity gets done in layer 2, the other half of the opportunity happens on a different layer 2. So, like, it might happen on StarkX, for example, or, it might happen on, like, on DYDX, or on some exchange running on Optimism. You might even have, like, an arb between the copy of Uniswap that's on Optimism and the copy of Uniswap that's on Arbitrum. So in this world, there are advantages from being the proposer for everything at the same time. And so now, it's not certain that things will go in this direction, right? But if things do go in this direction, then, like, we could easily see some kind of protocol take over that basically auctions off, like, kind of the right to be a proposer for these rollups as a package deal. And so you end up having the same actor end up proposing on all of them, even if the protocols are designed in such a way that you could have different proposers on them, right? So now, if the world does go this way, it's actually not that bad. The reason why it's not that bad is because rollups provide all of this protocol armor to make sure that even if there are centralized actors taking over, like, block proposing, they can't push through invalid things, they can't push through unavailable things, and because rollups all have these censorship-resistant bypass channels, they can't even censor anyone. Right? So the world of rollups where proposing gets concentrated is still a world that is not that bad. And also, interestingly enough, it's a world that is very similar to the world of one rollup or to the world of centralized chains, right? So basically, we end up potentially getting to a future that is very similar to the future that we would get in these other two worlds.
I think this all brings up the point to me then, Vitalik. If all three of these approaches result in the same thing, then why not just take the big block approach from the get-go and scalability? And are the alt layer ones taking the right approach after all?
I think the Ethereum approach is more future-proof, right? It's more future-proof because, like, it still leaves agnostic the question of, are we going to be in a single domain world or are we going to be in a multi-domain world? And it doesn't completely surrender on the centralization issue, right? Like, if it turns out that that the optimal way to organize proposers is some decentralized structure, where, like, for example, something like the existing Flashbots model, where you have this internal market consisting of searchers, then the Ethereum system is still friendly to that, right? So, but on the other hand, if you start from a layer one where you make the assumption of centralized proposing, then you don't really have a good way of getting out of that, right? So I guess the question is not is about the more you believe in uncertainty and the more you believe that we really wants to have a system that is open to all of the different possibilities, then the more kind of this Ethereum approach that is agnostic toward what the future will be, but tries to be friendly to and have ways to support all of them, looks the more that approach looks the most attractive.
It's funny to me, as much as Ethereum by maybe Bitcoin Maximalists and others has been criticized in the past for being, I guess, moving fast and breaking things too much. I often see Ethereum from a roadmap perspective taking a very conservative approach. It's a very conservative approach to decentralization, and in particular, it looks very conservative when you contrast it with all of these very high throughput, big block alt layer ones that have sprung up recently.
I definitely agree with that.
One of the dynamics that has really come about in the second half of 2021 is Ethereum just got so successful so quickly. The ETH price went from $600 in January of 2021 to $4,300 6 months later. And then it took a big crash, but whatever. There's this very, very strong incentive in the world of crypto for people. People obviously think that crypto is where you get rich really, really quickly. That's kind of what people think of our industry from the outside in. And when people look at the insane success that Ethereum has had, they want to emulate that success. They want to mimic that success. People want to get in on the ground floor of something. And I definitely think that incentive is one of the reasons why there's so many newer layer ones out there, is just because they incentivize so much just new users to come into their new ecosystem because it's brand new. And something that I think concerns me, Vitalik, about the possibility of one single dominant rollup on Ethereum is that if that happens instead of many rollups on Ethereum, then that concentrates wealth into that one single rollup, where there could have been 5, 10, 15, 20 rollups, each with their own token, each with their own ecosystem, that allowed so many people to get in on the ground floor of something that kind of answers to people's desire to, kind of have exposure to the growth of these ecosystems. And this has definitely been some of one of the big themes of the end of 2021 is users both want cheap blocks, but they also want to get in on the ground floor of something. How do you think, is that just a big wrench that gets thrown in the gears of trying to make a decentralized system? Or how do you tussle with this incentive that users have to always adopt something else?
Yeah, I mean, I think users wants to get on the ground floor, but then users also want stability, right? If you have a system whose entire legitimacy is based on the idea that this is a system that's where you can come in and still be early, then you're just setting yourself up to be replaced by the next cycle's version of the thing that lets you get on the ground floor and be early. And then if you wants to build something that lasts, right, then you wants to build something on a base layer that has a long history of lasting and that is going to last for and be relevant for a long time going into the future. So this kind of hybrid vision where Ethereum is the thing that lasts a long time and where you just keep having more layer 2 rollups pop up, it is an interesting hybrid approach, right? Because there is something that you can still get on the ground floor of, and there even is something that might be able to have more activist approaches to token issuance, for example. If you look at, say, Optimism's approach of retroactive public goods funding, that they're sending their transaction fees into, that is you basically get both that and you get the base layer that lasts a long time. And I think that is a combination that is really powerful. And you're right, that is not a combination that you get if you have Ethereum with a dominant rollup. And in the long term, it's not even a combination that you get inside one of these alternative layer ones whose marketing pitch is being on the ground floor today, right? Because like 10 years from now, their marketing pitch is not going to be you're on the ground floor. And so looking at what's going to happen 10 years from now, right? Like what's the ecosystem? It's not about what is the ecosystem that lets people get on the ground floor today. It's about what is an ecosystem that ensures that there is space for ground floors to appear 10 years from now. And like an ecosystem that allows for some kind of room for pluralism is pretty much the only way to do that.
Between the two versions of Ethereum's rollup future, where there's one dominant rollup versus many, many, many rollups, if in your own opinion, is one more desirable?
It feels like the single rollup one is more convenient for users, but the second one is like healthier in some important way. Right, like it's more fragile, more future-proof. There's more opportunity for things to improve if the existing approach goes bad for some reason. Whereas the first one is like, if you can make something that looks like Ethereum but it supports 10,000 TPS, then like in the short term that is a huge amount of convenience.
Vitalik, we've talked about so much on this podcast. Thank you for spending the time, the Ethereum roadmap, alternative layer ones, and the end game for all of these systems. And that is incredibly important. I think we want to end the podcast sort of where we started, but on the flip side, where we asked about your reflections on the previous year. Now I find myself kind of reflecting on the next decade and wondering, like, I think you tweeted this meme a year ago or so about the weird 20s, right? 2020s. And now we're 10% of the way through the weird 2020s, right? 10% of the way through this decade. And like for one, I think everyone listening want to avoid wars, global chaos, all of the things that we're seeing in kind of the news cycle as potentials, want to start solving some of the big problems in our world that just remain unsolved by the existing legacy institutions. Also, I feel like this need to make sure we don't just descend into this digital dystopia that appears all around us in various forms. Do you think crypto has a role to play in the 2020s in preventing some of the worst outcomes and maybe helping to usher in some of the best possibilities?
I think it really does. I think there definitely is this really important need for some kind of alternative to centralized institutions, right? Because like we're entering into a world where like it's not disintermediation, it's hyperintermediation, right? Like every transaction goes up to having lots of different actors that are in the middle. And a hyper-intermediated, centralized world is a world that can easily become dystopian, right? Because if there are like 5 different pressure points that I can lean on to stop a transaction between you and David, then like that's really friendly for anyone who wants to stop things from happening, because all they have to do is just to lean on any one of those 5. So if we want to have a future with the kind of intermediation that's necessary to, get the efficiency and all of the good things that we want out of the 21st century, then like there need to be some form of the like intermediaries that cannot be corrupted that easily. And that's, I think, is what blockchains provide. It is what decentralized networks provide. And like it's not just theory, right? Like this is something that I think in a lot of different ways people do recognize as a reality, right? Like lots of people, they've built startups on top of Twitter and Facebook, and then Twitter and Facebook shut down those APIs and their startups are gone in a day. I mentioned Argentina, like people there definitely understand a lot that, sometimes the local fiat currency really can't be trusted. And now maybe your local fiat currency in your country is fine today, but it might not be fine tomorrow. And if it's not, and just in case it's not fine tomorrow, then you might want to actually have some kind of alternative. If you're engaged in international transactions, then you definitely don't want something that goes through like all 5 intermediaries that consist of all 5 of the world's major geopolitical actors, because maybe one or more of those actors have very different ideas about what kind of transactions deserve to be allowed to exist than you do. So that is basically, moving away from this kind of world where hyper intermediation turns into like hyper choke pointization, and toward a world where these intermediaries can turn into something that is really empowering, is something that I think is really necessary. But in order to have that kind of world, blockchains have to actually be decentralized. Blockchains have to actually be credibly neutral, and blockchains have to actually scale, right? So that the blockchain can actually provide those benefits in practice and not just in theory. And I do think that we have a roadmap to make that happen, and I do think that there are a lot of people who are working really hard to doing a better and better job of executing on making that roadmap happen. So I'm very excited to see what the future is going to bring 5 or 10 years from now.
There you go. Crypto has made me more optimistic about the world as well. So is decentralization. And so have you in today's episode, Vitalik. Thank you so much for joining us on Bankless.
Thank you too.
Guys, a few action items for you today. We always leave you with these. The first is you can view that diagram of the Ethereum roadmap that I was referencing in this podcast we discussed with Vitalik. There'll be a link in the show notes. Also, take a look at some of the articles that we mentioned in the podcast as well. The Endgame article is one. There's a self-destruct article mentioned. Those will be included in the show notes. We also have some previous podcasts with Vitalik on Bankless, an episode on legitimacy, an episode on coin voting, and a few others we will include in the show notes. Guys, as always, risks and disclaimers. None of this has been financial advice. Ethereum is risky, so is crypto, so is DeFi. All of it is. You could lose what you put in, but we are headed west. This is the frontier. It's not for everyone, but we're glad you're with us on the Bankless journey. Thanks a lot.
Hey, we hope you enjoyed the video. If you did, head over to Bankless HQ right now to develop your crypto investing skills and learn how to free yourself from banks and gain your financial independence. We recommend joining our daily newsletter, podcast, and community as a Bankless Premium subscriber to get the most out of your Bankless experience. You'll get access to our market analysis, our alpha leaks, and exclusive content, and even the Bankless token for airdrops, raffles, and unlocks. If you're interested in crypto, the Bankless community is where you want to be. Click the link in the description to become a Bankless Premium subscriber today. Also, don't forget to subscribe to the channel for in-depth interviews with industry leaders, Ask Me Anythings, and weekly rollups where we summarize the week in crypto and other fantastic content. Thanks everyone for watching and being on the journey as we build out the Bankless Nation.